Welcome to Bald Guy DIY. In this video, I'm going to show you simply how you can take two ESP32 microcontrollers and transmit a set of values from one wirelessly to the other, essentially creating a remote control. As you know, if you follow my channel for a while, I've been posting videos that show little building blocks of Arduino code and how it works with the ESP32 so that you can do things like control servos or use joystick input and those kinds of things as I move towards a completed project of a remote controlled pan, tilt, and zoom video camera that I'm building to hopefully in the next few videos. On all the other videos, I've used one microcontroller and put all of the inputs or outputs on the pins for that single microcontroller. For my finished project, however, I don't want to have a cord carrying the signals to the servo motor and have to power it over a larger distance, which could be 50 feet or so. Instead, I want to use wireless control, and the ESP32 microcontrollers come with a standard called ESP NOW that was created by Expressif, the company that makes the chips. With ESP NOW, you can enable several different modes. You can do one-way communication between just one device to another device. You can do one to many, you can do many to one, or you can do two-way communication where individual microcontrollers are sending information back and forth. It gets really complicated in a hurry, and when I looked at different tutorials that were available online, I quickly grew frustrated because as I looked at other tutorials, as I looked for a good tutorial online, I found it frustrating because a lot of times they actually show you way more steps and way more complexity than you need in order to send a basic set of variables. In my case, I just want to send the analog values of the joystick as well as a few discrete push buttons. And so to be able to do that as simple as possible is what my main goal was. In this video, I'm going to show you the simplest way I could find in order to enable one-way communication from a sender to a receiver, sending one set of values, receiving it on the other end, and then putting it to work. So without further beating around the bush, let's get started. For this project, you're going to need at least two ESP32 microcontrollers. The instructions could be used for more than two, but in this case, I'm just going to show you how to do one-way communication from one controller to the other. I looked through a lot of different tutorials for ESP NOW, and I found out that the ones on Random Nerd tutorials were the most in-depth, although I did need to streamline them a little bit to make them a little more simpler. Simply choose ESP32, scroll down to the ESP NOW, and then choose the one-to-many option. Now, as you can see here, it's actually designed to be done with one microcontroller broadcasting to many, but in this case, we're just going to set up one. And as we scroll down, you can see here there's a test function in order to get the MAC address off the individual microcontroller. Now you're going to need this for the receiver only, so I copy that code into a fresh Arduino window and I put it in. You can see here it's going to simply include the Wi-Fi library, begin the serial monitor, set the Wi-Fi mode, and print the MAC address. When you open the serial monitor, you do find the MAC address is the last thing listed there. 24:62 AB, etc. And you're just going to copy that and put it aside so that you have it for later. Now, if you have your baud rate on your serial monitor set to a different rate than what was included in that code, you're going to see some gibberish like this. So you want to make sure that the baud rate is set to match what was in the script. And then when you reset your ESP32, you'll see that nice clean text and be able to see the MAC address as the last thing listed. Now if you scroll further down that page and you look at the default sender code, I've taken that code and modified it to make it a little bit simpler and a little more streamlined for the bare essentials. The first thing you need to do is include the two libraries, and then on the first variable there, the broadcast address, you want to replace the hexadecimal code with the MAC address and the way it's formatted. So you're simply going to remove the FFs that are there and replace them with the 2-digit that you have for each of those pairs in the MAC address. This next part is the most important part probably. It's how the message is going to be structured. It uses a struct variable, and we're going to set it up here, and you're just going to declare the variables that you're using inside of that structure statement. In this case, the basic ones are X and Y, but you could add another variable here, call it whatever you want. I just show you what Z would look like there, and whatever it is, whatever fits in that statement, that's the variables that are going to be available to be sent to the other microcontroller. Now you can see here You also declare the name of the structure message. As you can see here, mine is called example. Now below that you see this function called onDataSent, and this includes a lot of the technical information that the ESP NOW library requires. So that's already set up. No need to go into the nitty-gritty of it. I can't say that I understand exactly everything there or why it's necessary in the format that it is, but that's what the library requires, and so I simply copy and paste. Don't need to change any of that. If you look in there, you can see that there is an option for multiple MAC addresses, and those different MAC addresses would be available if you were sending to more than one microcontroller. Because we're not, you can just ignore it. They won't be used. Some of those functions are just printing to the serial monitor, just to let the serial monitor know what's necessary. Although I have noticed that if you remove some of these serial prints, it stops working as well, and so I think the library must require them in order for it to work. If we examine the setup function, we can see here that it starts the serial monitor. That's pretty normal. And as I mentioned before, if you see gibberish in your serial monitor, it's probably because the baud rate of the serial monitor is set to be different than what you declared here. So that 115,200 is the baud rate. If yours is set to 9600 on the window, you're going to see a bunch of gibberish on the screen. Sets the Wi-Fi mode as Wi-Fi station, and then it has this initialization prompt here, which checks to see if it's getting communication and then returns the function. As you can see also, it registers that onDataSent function that we declared earlier, and all of these steps are necessary in order for the correct protocols and things to be established. For the vast majority of people, we probably never need to adjust these things. You'll see them over and over again in example code, and there's really not much need to change them. Maybe if you had very specific circumstances or you needed data encryption or something like that you would add it, but I don't know about you, most electronics projects I'm working on aren't really a target for hackers. This mem copy, or MEMCPY, is very important because it's going to take the broadcast address, copy the information that you're wanting to send to that broadcast address. Now, if you wanted to send to a second or third or fourth microcontroller, you could also here just copy and paste those sections, change the broadcast address, and you'd be good to go. There is a setting above where you set those broadcast addresses at the beginning with their MAC address, so of course you'd have to copy that as well. But if that's what you're desiring to do, the one-to-many tutorial on randomnerdtutorials.com works just fine. The last part of this code is found in the loop function, and you can see here that the variables are populated just by using random numbers between 0 and 20. What's most important to note here is that the variable has to be prefaced with the name of that structure message. So if you called that structure message as I did example, then it must be example.x, the x variable inside the example structure message, or if you're going to declare the y, it's example.y, etc., etc. The code here is also just going to print out those variables to the serial monitor on the sending device, so that if you want to make sure it was functioning properly, you'd see them displayed over and over again. As it's part of a loop, every time it goes through the loop, it's going to generate new random numbers between 0 and 20 for each of those variables, and then it's going to print those to the screen and send them off. This statement here is the most important thing as far as actually sending the information to the other microcontroller. Here I had an old name of a structure message, so it contains the name of the structure message, which is example, and it also declares the size of the message and makes it ready so that it will send to the correct place with the right formatting. This last little bit here is an if statement that is asking if the result is equal to ESP OK. I did find that it was possible to comment that out and it still worked, so I don't think it's particularly necessary. But if you're having some issues, you could always uncomment it, or if you're having issues, you could always recomment it and then make it active again. In my situation, I haven't found any use for it, and I'll probably delete it. Finally, there's some delay added just to decide how long it should be before this whole process is initiated again and new message is sent. Depending on your circumstance, you can adjust that greatly. In my case, I want it really fast, and I'm going to change it to much quicker than 2000 milliseconds. The bare minimum for receiving is simpler than it is for the sender, because the receiver doesn't need to know what any of the other addresses are. It only needs to know what the message is going to look like. So we include the same two libraries at the top, and then we define the same structure for the structure message as we did for the sending device. Now, you can maybe get away with some discrepancies between the two, but best practice is definitely to declare it exactly the same as you did for the sending device, and then you don't have to have any issues. You'll notice that the name of the structure message can be different than it would be on the sending device, and if you're sending and receiving between the two devices, you definitely want to name it something that's meaningful, such as incoming and outgoing. In this case, it was just named my data, and I just left it as that, but you could call it anything you want. Just realize that as you get down to a place where you're going to use those variables, you're going to use the name dot the variable name, just like you did for example.x. So in this case, when we use those variables, they're going to be mydata.x or mydata.y, because that's how they were declared in this particular code on this device. The onDataReceive is the most important function in this whole code because it serves as the loop function. The loop function on the receiving device will be empty, so everything that you want to happen with the data that's received is put into this onDataReceive function. It's going to start by copying all of the myData structure message into the variables that were declared there, and then all of the code beyond that first MEMCPY or memcopy is going to be what you do with that information. Now the default in the code that was provided by Random Nerd Tutorials is just to print out what each of those variables is so that you could see that the message has been communicated. Obviously for most people you may want to put it on a screen or something like that, some kind of display, but you also probably want to control some outputs. In my case, I want to be able to control servo motors, so I'm definitely going to be messing with the code inside this function. The setup loop is a little simpler as well than the others. You're just going to start the serial monitor again at 115,200 baud rate. You're going to declare the Wi-Fi mode again as Wi-Fi station, and then you need to do this initialization statement which gets the ESP NOW protocol running. The very last step is just to register this device to make sure that it receives the callback and declares it on the onDataReceive function. As I mentioned, the loop function is left empty because all of the work's going to be done inside of that onDataReceive. That's all it takes for the bare minimum code on the receiving device. If you haven't yet watched my video on the pan tilt mechanism, now would be a good time to do that, or at least be aware of the kind of code that I use there. This is the sending device's code that's required for the pan and tilt mechanism to work. So I'm going to use all of the same things that were required for the bare minimum, but I'm also going to add all the code that's necessary for the pan tilt mechanism. Now, as you can see here, I declared the pin values to be different, and this is a really important distinction when you're using the ESP NOW protocol, is that all of the usual pins that I use, like 2, 4, 5, 18, 19, etc., none of them work because they're on the analog to digital converter 1 on the chip, and so we need to use pins instead that are in the analog to digital converter 2, which is not all taken up with the Wi-Fi protocol like the ADC ones are. So in this case, you need to use pins like 34 and 35 and 32, etc. So if you need to look up that distinction, just look up the ADC 2 pins on ESP32 and you'll get the full list of them there. Just like we did on the bare minimum, you need to declare the MAC address for the device that's going to be receiving these messages. And then you need to set up the structure message and the variables that are going to be sent from this sending device to the receiving one. In this case, I'm going to use X for the X-axis, Y for the Y-axis, and then a switch value for the push button that exists when you push down on the joystick. Because the structure message is related to joystick, I'm going to label it joystick, and that's going to carry through to the names of my variables as well. Just like before, we have this onDataSent function, and we're not going to adjust any of it because it seems to be necessary, and really there's no need to declare anything unusual from what's already here. The setup loop is very similar to the other one. All of the same serial monitor starting, Wi-Fi mode declared, initialization of the ESP NOW protocol, and the onDataSent function laid out there as well and registered properly. This is also where you're going to register those individual devices that are going to be receiving the message. And once again, if you wanted to send to more than one device, then you would simply declare each here in this particular location. The relevant code for my pan tilt mechanism is just that the joystick button needs to be set up here. So I'm going to declare the pin mode for the switch pin and call it a pull-up input, and so the code knows what to do with it. On the sending device, the loop function is definitely deployed, and so here we're going to declare the values for that structure message that's called joystick, and we're going to read the corresponding pin for the x-axis and y-axis of the joystick and then put them into those variables, and also the switch value. Because it's an input pull-up, it's going to be 1 if the button isn't pressed and 0 if the button is pressed.
Just for the sake of reference and troubleshooting, I printed those values to the serial monitor so that you could see if there was a problem. And then of course we need that same message that's actually going to send off the message that we created, joystick, and it's going to send it off to the addresses that have been declared, and those devices should hopefully receive the message and take appropriate action. Once again, I just commented out that default code that's there to check if the message was sent successfully, and I've adjusted the delay from the 2000 milliseconds down to 90 milliseconds, which is pretty close to the 100 milliseconds I was using when I wasn't doing the wireless communication. Of course, this will really depend on what type of application and how often that information has to be refreshed. The receiving side might look a little more complicated, but really, for the most part, it's the same as that bare minimum, except that I've now inserted all of the relevant code for the servos and the servo control that I had in my pan and tilt video. So here, I just simply copied all the code for the servos, which was the servo library, declaring both the servo objects, the tilt and the pan, and then creating variables for their position and which pins they used, what values were stored, all of those kinds of things. So all of these things are in place to interact with the structure message that we receive from the sending device and can now be used to deploy instructions to the servo. Structure message must match the sender, and in which case it does here X, Y, and switch value. And you can see I kept the title My Data, though I could have called it something else. I think if I do a video on two-way communication, I'm going to call them something distinctive so it's very clear which one's which. Maybe something like cereal names like Fruit Loops or Frosted Flakes, just so it's something that stands out. Something as generic as My Data. You might not realize if that's actually the name of the message or if it's one of the variables that's required by the code. So I like to name it something memorable so there's less confusion. That onDataReceive is again the most important function in this code because this is where all the action will happen once that data is received and copied to the variables with that memcopy command. Everything that happens after memcopy is what you're going to do with that data. In this case, I kept that original code that's going to print all of those variables to the serial monitor. Again, just for the sake of troubleshooting, I could pull up the serial monitor and make sure that I'm receiving the correct values. But then I just pasted in all of the code that I used in my pan tilt video when everything was wired together in one microcontroller, and then I just made a few tweaks that were necessary because the names of the variables have changed. If I scroll back up here, you can see that instead of just calling X value the analog read of the X pin, I now am calling the X value the value of mydata.x, and the Y value is the value of mydata.y. The switch state is now mydata.switchValue. Now I could have gone in and changed all of those things so that instead of X value here it just said mydata.x, but I didn't want to have to change a bunch of the code. This way it's more relatable to the video I did before, and there's less changes and adjustments that are needed. Of course, use the same kind of functionality, all of the if statements that are going to determine which way the joystick's actually pointing, depending on the values of those analog axes. And then I just finished the code up like I did before, putting those outputs to the servos. In the setup loop, this is where we're going to just simply declare the serial monitor, the Wi-Fi mode, initialize the ESP NOW, and register it. Those are the default values for ESP NOW. For the sake of my code, if you look at my previous video, you're going to see also that the ESP32 needs to declare some things in order for servo operation, including all of these PWM timers, and then of course the hertz for the servos, and also just attaching those and getting them ready so that they will write default values of where I want them to start. The loop function remains empty, so that's the end of the code for the receiving device. Let's give it a test drive. As you can see here at the bottom of the screen, I have one microcontroller, the sending unit, in my hand, powered and connected by wires to the joystick, and then there are no wires connecting that first microcontroller to the one towards the top of the screen. That one is receiving those variables wirelessly and transmitting them to the servo motors of the pan tilt mechanism. It works.
As you can see, I tailored the experience of the tutorial to the pan and tilt mechanism that I showed in my last video, and I'm going to keep adding complexity, but this is the basic format in order to create those structured messages and have them received on the other end and putting the variables to work to accomplish anything that you can imagine. So you really could take the instructions from this video and make almost anything as long as the only thing you need is one-way communication. If you'd like to see how two-way communication works in a simple way and hopefully broken down in a way that you could easily apply to your own project, let me know in the comments if you'd like to see that video, and I'd be happy to make it down the road. I'm getting a little anxious to get this whole pan, tilt, zoom camera mechanism ready, but I'm still waiting for the video camera itself to arrive from an online order. In the next video, I'm going to show how to store and retrieve variables from the internal flash memory of the ESP32, which will be really important with my wireless control to make sure that even when there's a power outage or the power is cycled, it'll still remember all of the saved settings that I have. Of course, I'm not talking about the actual code on the ESP32. That remains saved every single time. But if you want to be able to keep the values from your variables and use them again the next time that the whole project is powered up, then you need to be able to write to that internal flash memory that won't get wiped when the power gets turned off. So if you're interested in storing and retrieving information from the flash memory, stay tuned for the next video. If you like these videos, let me know by giving the video a thumbs up, leaving me a comment to let me know what you liked, what you'd like to see further explained, and any ideas for other videos you'd like to see down the road. Subscribe to the channel, tell your friends and family about it. I'm always happy to see the subscriber list grow, as I know the content that I'm providing is helping somebody. If you'd like to send me an email or follow me on Twitter, my information's in the description below, and check back every week as I post a new video every Saturday morning. Until next time, in your DIY projects, especially those with built-in wireless communication, don't be afraid to cut the cord and be a little bolder.